This is a simple JEE advanced question in sequences and series. Let the AP, small letter a and d, represent the set of all terms of an infinite arithmetic progression with the first term a, common difference d, where d is greater than 0. They're talking about the intersection of an AP with the first term as 1 and common difference 3, and another AP with first term as 2, common difference 5, and another AP with the first term as 3, common difference 7, is a new AP which comprises of the terms common to all the three APs whose first term is A, common difference is D. Find the sum of A and D. A simple question. So let's write the first AP. It looks like 1, 4, 7, 10 and so on. This is the first AP. The second AP is 2, 7, 12, 17, etc. This is the second arithmetic progression. The third one will look like 3, 10, 17, 24 and so on. So literally they are talking about the intersection of the three APs. So by looking at it, we don't find any element which is common to all the three to start with. So let us take the first two APs and take a series that is common to both. You can see that the common term to both the APs is 7. So the series common to 1 and 2, intersection of 1 and 2, common to series 1 and series 2, the first term of that series is going to be 7, and here the common difference is 3, here the common difference is 5. So the LCM of 3 and 5 is 15. So our common series to 1 and 2 will have a common difference as 15. So it will go as 22, 22 plus 15 is a 37 and so on. Now we need to find a series common to this and 3. Let me write it in the next slide. 7, 7 plus 15 is 22, 22 plus 15 is 37 and so on. This is a series common to the series 1 and series 2. Series 3 is 3, 10, 17, 24. 3, 10, 17, 24, etc. Now you need to find a series common to these two that will give us the required series, but you can't see any term which is common and we can't be writing indefinite number of terms. Let me take a general term of series A and series B. General term of A, of series A, is going to look like 7 plus some n1th term. Instead of n, let me call n1, n1 minus 1 into 15. So this is going to look like 15 n1 minus 8. So similarly, let us write a general term of 2. General term of B is going to look like 3 plus some n2 minus 1 times 7. Why am I bringing in n1 and n2 means uh, the 10th term of this is not going to be definitely equal to the 10th term of this. This is increasing at a faster rate. Its first term is bigger, common difference is bigger. So you will never have the 10th term of this equal to the 10th term of this. The 10th term of the first series will be equal to some 15th term of the second series, because the second series is increasing at a much slower rate with a first smaller first term. So the some term of this series will be equal to some other term of this series. So I am roping in an n1 and roping in an n2. So from here we get 7 n2 minus 4. So for some n1 and n2, these two should become equal. That means 15 n1 minus 8 should be equal to 7 n2 minus 4. n2 has a smaller coefficient. Let me keep n2 as it is and shift this 4 to this side. So I get 15 n1 minus 4 is equal to 7 n2. Or I can rather write it as n2 is equal to 15 n1 minus 4 divided by 7. You can simplify it further also. We can see that 14 n1 is divisible by 7. So I will write this 14 n1 by 7 as 2 n1 plus n1 minus 4 divided by 7. Now we know n1 is a term of a series, n2 is a term of a series, so they have to be positive integers. So you can understand that n1 minus 4 should be divisible by 7. So the smallest value of n1, so that this is divisible by 7, is n1 is equal to 4. When you put n1 is equal to 4, you get n2 is equal to 8. That means the fourth term of the first series is equal to the eighth term of the second series. Similarly, let me take one more value. This should be divisible by 7. That means I will take the next value of n1 as 11. 11 minus 4 will be 7. 7 by 7 will give me 1. So 23 will be the next term. So the fourth term of the first series is equal to eighth term of the second series. Similarly, the 11th term of the first series will be equal to the 23rd term of the second series. So let me write the common series. I will pick the common series from here. When I put n1 is equal to 4, n1 is equal to 4, it will become 60 minus 8. So common term, common series to all three, intersection of all three series is going to be, it's going to have the first term as, you put n1 is equal to 4, 15 into 4 will be 60, 60 minus 8, 52 will be the first common term to all the three. Next you put n1 is equal to 11, 15 11s are 165, 165 minus 8 is going to be a 157, 157 and so on. They are asking us to, this is the common series, they are asking us to find out a plus d. So you don't have to find a and d, you know that any AP will be, a will be the first term, a plus d will be the second term. In fact, they are asking you to find the second term of the common series. So the value of a plus d is equal to 157. A simple question, but it was tested in JEE Advanced. Only difference between the way it is tested in JEE Mains and JEE Advanced is there is a notational difference. Normally in JEE Mains they will give you the series and ask you to find out the common term, number of common terms and things like that, but they have used a set kind of a notation, intersection of all the three series. That's what they are talking about. They are asking you to find out the new AP, which is the intersection of all the three, and literally asking you to find out the second term of that series. The second term of that series is nothing but 157, which is the required answer.